hearing from me and from Kelly Love and Trey Avery this morning, but it does actually take a cast of thousands to implement these things, and so we do want to acknowledge some of our other wonderful colleagues. Amongst many others, they've been really instrumental in getting this work off the ground. So first of all, my lab, my whole lab, which is a lot of people, most of whom aren't able to be here today. It's the Neurocognition of Language Lab. I'm the lab director there, and Trey is the lab manager, as well as being a doctoral student. But we're collaborating with 2 other centers to make this kind of work possible. One is the charter school in the Bronx, where Kelly is based, and she'll be telling you about that shortly. And the other is the Center for Children and Families here at Teachers College, where Dr. Jean Brooks-Gunn is the director, and Dr. Anne Martin is a research scientist. We're immensely grateful to both of those people and their group for their collaboration and their hard work on this project too. We're also very lucky to have a wonderful lab assistant who is here today. That's Mariah DeJoseph. She's a candidate in the master's program in Mind, Body, and Spirituality. She is just wonderful at working with kids of all ages, like right up to my age. I can vouch for this. So we really wouldn't be able to do this work without her assistance as well, so thank you, Mariah. Thank you to all of our collaborators who weren't able to be here today. What I'll do first is give you a brief outline of the talk, and then we'll actually get going. So first up, we'll have Kelly Love, who's going to talk about the mindfulness program that we've been investigating. Girls Prep is a charter school in the Bronx. So it's probably immediately obvious that it's a pretty special place to have somebody like Kelly on the full-time staff. She's a permanent full-time member of the teaching staff, and she's there in order to provide regular instruction on yoga and mindfulness for all the students at the school. You're going to love hearing about the work that she's doing. It's extraordinary. Then you're going to have me back for a quick primer on brain science, of all things. I'm going to try and teach you what we know and how we do this work in about 15 or 20 minutes. So I hope you will blow up those brains of yours and you're feeling ready for that. It's going to be very quick, but hopefully it will get everything established for the next and maybe most important part of the talk, which is about the actual research that we've been doing into mindfulness. And that's going to be the nitty-gritty for today, and that's going to be presented by my awesome lab manager, Trey. He's going to tell you all about that and then wrap things up into hopefully a little bit of time for questions and discussion towards the end. So let's get going. Please welcome Kelly Love.
I would like to first let us get started with a bit of practice, since that's the cornerstone of mindfulness. If you can, if there's anything in your hands, if you wouldn't mind just setting it aside. If there's something on your table, no worries, just let that be there. So that I know we have some people standing and that's fine. So if you're sitting, just take a comfortable seat. If you're in a chair, see if you can let both of your feet be on the floor. Just so that you can feel the sensation of your feet standing or sitting or your legs touching the floor.
What if you're too short?
So move forward, yeah? On the edge of your seat. Perfect. And then once you get comfortable, see if you can let your eyes close. Or you can just look down. Either of those work. And the next thing I'll do is bring the singing bowl. And what I want you to do is see if you can just focus all of your attention on the sound of the singing bowl. So we'll practice mindfulness of listening. When the sound of the singing bowl is finished for you, I'd like you to raise your hand, okay? Just to show that the sound is finished. And the next thing we'll do is place our hands either on our heart or belly, either one works, so that you can feel the sensation of your breath rising and falling. So just let your eyes stay closed and let your hands feel the rise and fall of your breath. And just allow yourself to take 3 regular breaths here. Bringing your attention to the in-breath and the out-breath. And the thing about mindfulness is that we don't have to change anything at all. We're just paying attention to the breath exactly as it is. And see if you can use your mind to focus your attention more by saying breathing in as you inhale and breathing out as you exhale. So you have your hand and your words to anchor your attention to the breath. And we'll practice for about 1 minute. See if you can notice any time your attention wanders away, and gently bring your attention back. And I'll ring the sound of the singing bowl again. And when the sound of the singing bowl is finished for you, you can open your eyes. And just notice how you feel now. So when we practice mindfulness at the school that I work at, Girls Prep Bronx Elementary, that's an element of what we might call focused attention in mindfulness, and it's the core practice of what we do in every class. And the thing is that all kids are told to pay attention by grown-ups and all kinds of people in their life, but kids are never really told how to pay attention, right? So that specific practice of mindful breathing can give kids a tool of constantly knowing how to come back to one pointed attention. Before I go on, just to give you a sense of the program, I love to show a film. It was told from the perspective of one of our parents. Ultimately, the reason that I chose this parent to tell the story of our program, it was because she kept coming and telling me several ways that her daughter was implementing, or not implementing, but basically translating the learning that we were doing in our classroom to home. I'm constantly getting these stories where the learning of mindfulness is being integrated into everyday life. And so this short film just kind of shows what it's like to learn about focusing and regulating emotions through a school-wide mindfulness program.
I look at my daughter, she's 6 years old, and I wonder what's going on in that little mind of hers. Trying to get Aliza to focus is one of her big challenges. She has tantrums. She gets frustrated and everything around her becomes a target. When we have nights like this, I have no idea what to do. I'm feeling incompetent. I'm feeling like I can't do this. I'm not a good parent. I reached out to Miss Love because this is a teacher that she sees 3 to 5 times a week who's teaching her how to learn about what's going on in her body, learn the emotions, yoga practices.
Shining stars does the Ruby Bridges class need?
When Zarita reached out to me about Aliza's struggles with attention, we made a plan for ways Aliza could use the focusing techniques we do in the yoga room to build attention skills.
Please put your hand mindfully on your anchor spot, your heart or belly. Breathing in, breathing out. Nice, Taylor. 1 minute of mindful breathing all by yourself with your hand on your anchor spot, your heart on your belly. Which one do you use, your heart or your belly? Your heart. Okay, so you're going to really feel your breath here. And you notice when you're saying your anchor words in your mind. Can you say them with me? Close your eyes. Breathing in, breathing out.
In yoga and mindfulness, our job is to be really curious about what's happening inside of ourselves. I want you to write, I wonder, and write about one of your feelings on the inside. So I'm going to read Layla's to help give you an example, okay? Layla's wondering,
I'm wondering why I get so disappointed at my brother.
I wonder why I get so disappointed at my brother. Okay. We're going to practice saying, I am so focused. Okay, in a calm and sweet voice.
I am so focused. I am so focused. I am so focused.
Now whisper.
The next thing we're going to do is layers of sound.
Open your ears really big and see if you can notice any sounds you hear outside of the school. Our job is to be curious today about what we notice. Now, bring your attention to sounds inside of our school, but outside of the yoga room. I'll open the door. Just listening. And see if you can really listen to any sounds that you might be hearing inside of you. Put one hand on your heart and one hand on your belly. Come up to sitting. I'm so curious about your noticings. We're working on being curious about things we hear outside of ourselves and inside. The next thing we're going to do is use the glitter bottles or our mind jars.
A mind jar is a glitter bottle. When you shake it, you put it down and see how your brain is moving around. You use it when you have strong feelings. It just makes me feel mindful and calm.
Yoga time is ending and we are lying down. Bellies up. Make a singing bowl in front of your heart, an imaginary singing bowl. Grow your heart really big. Put all of your kind wishes in your singing bowl. And send the love and your wishes out to the world.
It's kind of like having a safe haven in your pocket. This was something different that I had not seen in elementary school ever. Having the techniques that Miss Love showed us helps the girls to concentrate on their work. Relaxation before bedtime. I feel honored, I feel privileged that my daughter is going to a school that actually incorporates yoga and mindfulness.
I'm tired.
I wish I had yoga when I was young.
Can you tell me why? It sounds like fun.
Because it is.
Oh, really?
You might love yoga. Maybe you do it 1,000 times.
Imagine you have a bottle of bubble soap. Open the lid. Take out the magic bubble wand. If you want, you can close your eyes. Now imagine that you blow a bubble. It gets bigger.
So, as I was watching that, one of the things that I was thinking about is that really one way, and there's lots of ways to describe what mindfulness is, one way to describe mindfulness is that it's shifting our attention, right? Knowing how to shift your attention to what's happening in the moment. And a lot of times, just when we think about our modern world, it's really a struggle to pay attention and to know how to direct and manage our attention. And so several of those strategies help the students regulate their attention. For me, it's about having a school-wide program and enculturing the whole school culture so that it's pervasive and there's a common language. So just to talk about a little bit the implementation for a minute or so, you saw that not only do all the students come to the yoga room, but also I lead the parents separate from the students. That's their regular monthly PTA meeting where they get time to experience the practice separate from their daughters. And then also once a month we have a yoga night so that parents get to connect to their daughters and they get to understand the practices so that they translate to their home experiences. Lastly, sometimes I'm going into classrooms so that the teachers cultivate a common language, and then again, so it just becomes pervasive in the school culture, and through that way, you're changing the world. That's a family yoga night. You can see that the students are really interested. They have a lot of enthusiasm for the programming because they see how effective it is for themselves. So they invite their families. So that's just an image of them practicing at family yoga night.
I don't have that smile on my face when I'm doing yoga. And then here we've got some of their notebooks, right?
Yeah.
This is where we get to see how familiar they are with their brains, which is wonderful. Look at this, PFC is saying, don't open your eyes. And that's exactly the prefrontal cortex. It's telling you, like, regulate your behavior, modify your behavior. It's changing the way the brain is working.
Every time after we do mindful breathing, I like to ask them, just like I asked you, notice how you feel. And then we have a conversation about what happened during the mindful breathing. So Jocelyn, who loves to write about what happened, she actually begs me, can we write in our journals today about what we noticed? When I did mindful breathing today, I noticed my eyes opened because my amygdala said, open your eyes. And by the way, she's 6. But my PFC said, don't do it. But I noticed that my eyes and my puppy mind ran away, but I brought it back. and I still felt calm.
That's wonderful. I have grad students that don't know that.
And then what I love about this work is Leilani says, and she's also in 1st grade, when I did mindful breathing today, I noticed that I opened my eyes, and I noticed it. So I closed my eyes, and I was being mindful when I noticed. To me, that's the most powerful part. The students don't think that you have to stay focused all the time. The noticing of the wandering mind and bringing it back, that's the mindfulness. That's the awareness and the regulation of what's happening.
When I do mindful breathing, my PFC grows. Yeah. That's great understanding. Okay. All right, so now everyone's feeling mindful and focused and calm, right? So I'm going to work with that. Thank you for the setup. Because what I want to do now is really give some context about the application of neuroscience in educational settings and to questions of importance for educators. We have a unique environment here at TC. It's already been mentioned. Thank you to Goldie for the setup this morning as well. Because we really are the only school of education that has dedicated neuroscience research facilities right here. You know, we don't have to go somewhere else to borrow equipment or borrow expertise. We're neuroscientists working in a school of education. And that's very unusual, unique even. So why this kind of research can happen at Teachers College, we have this amazing kind of combination of a school of education that's doing neuroscience research in the Neurocognition of Language Lab, which is my lab. I may have mentioned, but I'm very proud of my lab. You'll be hearing more. And the National Center for Children and Families is right here also, that's actually was established to apply interdisciplinary approaches for changing and improving pedagogical practice and supporting families. So we really have this wonderful kind of cross-disciplinary situation that makes it possible for us to look at these things. I promised more about the lab, so here's a little bit. This is over here. This is actually our lab, although it's usually much fuller than that. I believe everyone was standing right behind the camera waiting to get back to their workstations. This is our view. Isn't that great? This is the view from the lab windows. And I think that's unique too. It's the only lab in the country that has that view. Apart from the lab next door to mine, which has a very similar one. But with this, you know, it's inspiring, it's opening. You get to open your mind. If you need to refocus, you can just look out the window. So it's wonderful to have. This is the more technical nuts and bolts end of where we work. This is where we run many of our experiments, and I'll be explaining a little bit more about the methodologies that we use. And of course, we have to thank and acknowledge always the wonderful people from very young ages to very old ages who come in to actually help us with all the different kinds of experimental work that we're doing. Obviously, we can't do this without willing participants, and we have many, many. We're recruiting for a couple of studies at the moment, so if anyone is interested in taking part, then please, you know, take a look at our website and come and join us. We promise to take good care of you and your brain. Okay, so I'm asked quite often why a neuroscience lab even exists in a school of education. And my usual response to this is something about the nature of learning and experience. So if you care about how people learn, then de facto you care about what's happening in their brains. So we use neuroscientific investigations to help us evaluate questions about learning and cognition in an objective way. And by looking at the brain, what we can also do is really look at sub-processes that are related to complex behaviors. If you only look at behavior, what you're seeing is really the end result of a lot of other things that have happened. I'll talk more about that in a moment. It's an important concept for us. You might already have noticed that cross-disciplinary work is really important for us. We are neuroscientists. I'm a linguist by training, and before that I was a speech pathologist, so I bring those kinds of expertise to the situation. We also work with educators, psychologists, other linguists, speech pathologists, other clinicians. We really need people with that kind of expertise, classroom expertise, real-life expertise, clinical expertise. That's what informs the application of our research, and it's really how we generate our research questions in the first place. So the cross-disciplinary work is absolutely crucial to us. The other side of that is that we're doing brain science. And I have a good friend who used to say, you know, it's not rocket science and it's not brain surgery, but it's brain science. And that's somehow kind of the most complicated bits of both of those worlds. So even within the neuroscience piece of it, we need statisticians, engineers, physicists, various kinds of experts that, you know, I only had time so far to get one advanced degree, unfortunately. So, so we do need to call on a lot of expertise just to make these things work. So the cross-disciplinary work is just bread and butter to us. It's absolutely basic. And we conduct investigations then that have the potential to be applied in all kinds of educational, pedagogical, and clinical situations. In some labs, the way that they work is more a kind of doing the research, doing the hard science, and then later on trying to figure out how that can be applied, how to translate it for the people at the grassroots kind of level. That's never been how we've worked, and partly because we're here in this school of education, what we actually do is from the very beginning, we're thinking about applications. We have questions about learning in classrooms, about learning disabilities, about speech and language, acquiring languages. Why is it harder for adults than for children? What can we do to make it easier? All of those kinds of questions. So we start with the application. We do the science to inform these questions that are already of direct relevance for teachers and clinicians and educators. So we hope that our investigations inform clinical interventions, pedagogical approaches, things that people can actually implement in the classroom, educational policy, because there is a new and rather slow recognition that brains actually really do matter, and that you can change classrooms, change learning environments, and change approaches to support brain development, and that will support learning and cognitive development. And we also have a very strong thread and tradition of looking at issues of social justice and equality. Because if you care about everyone having access to learning, everyone being able to reach their full potential, then you're really looking at those people who don't immediately fit in with current educational practices or environments. We're looking at ways to adapt things, make them better, make them more available, and make things more accessible for everyone. So for me, that's an extremely important piece of what we do, and it really matters to all of us. So I'm very proud of that aspect of our research. I did just want to mention that we don't just do meditation stuff, in case it's starting to sound that way. I'm not going to bore you with the details of all of these studies, but I wanted to give a little sampling of the kinds of things we're looking at the moment. We're looking at brain processes that support adults who never learned to read and who are trying to acquire that skill much later in life. We're looking at speech perception in childhood apraxia of speech, which was always thought to be a motor planning disorder for talking. But now we're finding out that in fact there's a perceptual problem with that as well, and we can examine that much more effectively by looking at the brain. We're looking at early language learning. Arabic is a key test case for us because most speakers of Arabic speak at least 2 or 3 languages just by default. So we're looking at how people manage to acquire multiple languages just because that's what's in their environment, how the brain supports that. As you know, we're talking about attention, stress, and mindfulness in children, kindergarten and through elementary school. We're also looking at attention and stress in adults. We've been working with some of the mindfulness programs, the MBSR programs you might have heard of, this 8-week kind of mindfulness training program, and looking before and after meditation experiences in adults to see what changes we can identify. MMN, I won't bore you with that at the moment, it's a particular brain signature of auditory processing. And we're looking at the utility of that brain signature to help us understand when language impairment might be present in autistic children who are much younger than are able to participate in language testing. So then that could hopefully mean that we can get intervention to those kids earlier, and that will be more effective for them. We're looking at the brain processing of vision in people with dyslexia. So very, very basic visual processes appear to be they appear to be involved in difficulties in reading, which is far from a basic visual process. And I will be talking about reading just a little bit. We're looking at the neurophysiology of reasoning. This has been a really fascinating study that's got a lot of applications in the classroom. We can see different brain networks being engaged when we ask people to take part in different kinds of problem-solving activities. So then we can start thinking about this kind of neuromyth about people being, you know, just visual learners or rule-based learners or whatever. And we can start to show that's really not the picture. That's not what we're seeing. The brains are much more adaptive and much more engaged in different ways and can flip between these different networks for different problem-solving tasks. And we're also looking at perceptual learning of lexical tone, which is a big problem for anyone who's trying to learn a tone language that wasn't exposed to it before. So adults trying to learn Chinese, for instance. And we've got a large population at the moment where we're really examining why Chinese is considered to be hard for people who grew up speaking English. So that's just a taster. We've got, you know, there's a whole kind of smorgasbord going on. What I'd like to do now, since we've been doing very experiential kinds of things, is I'm going to administer, I'm not going to make you dance. I can see how that looked bad. No. No. This is a reading test, okay? So we're going to do a quick reading test. You're going to see these words come up on the screen and you're going to read them for me. Okay, so this one says, yes. Good, okay, nice. We're going to do it as quickly as we can.
Kitchen, admire, cyclone, situation, bright, aesthetic, nuance.
Nice, wow. Okay, wait, go back. All right. Okay, that was super fast, right? You see a word, you read it, there's no gap, right? Extremely, extremely quick. At least that's how it seems. This is not at all the case. That's really not what's happening there. So when you read, you have to do a lot of things. I wanted it to go back. Why didn't it? Bend it to my will. Okay, kind of. So when you read, you're doing actually a lot of things. You are perceiving these kind of lines on a page, and you need to use your visual system for that, right? You're understanding that these lines on a page are not just lines on a page, they actually have a linguistic kind of meaning. You're mapping those linguistic meanings that are associated with those lines on the page to phonological categories, which means speech sounds, right? We have all of this information stored in our brain, so you map between these different kinds of things. So now you're involving your visual system and your auditory system, like auditory memory, so that you know what sound is associated with each of these little squiggles. Then you have to figure out what do the lines on the page and the sounds that belong to them actually mean, right? What's the semantics of that thing? You have to do some other kind of really complicated things, like taking those meaning representations and checking to see, is there a way to actually pronounce that? How do I make this into muscle movements, right? How do I flap my lips and tongue and teeth and vibrate my larynx and breathe at just the right moment to actually produce that? And then you still, even then, have to send those instructions to the muscles and ligaments that are involved in producing that actual sound. And then you've got to actually get it out, right? Which is not a small thing. You might have noticed I speak fast. And I have an accent. I'm British. It's not a disorder. It's a real thing. So when you talk, you actually use those articulators, those muscles, in sequences. You can't believe how fast and complex this thing is. And the brain is constantly doing that. Not just doing that, but also monitoring what comes out of your mouth. So a few minutes ago when I fell over my words, my brain was able to monitor that, find a way to correct it, push the information around to where it needed to be, and then get the right pronunciation out within, you know, a few hundred milliseconds. This is a very, very fast process. Now, as educators, if we care about something like reading, which is a very complicated kind of process, by the way, all of those words on that list are real words from grade level reading lists. Those last couple, aesthetic and nuance, those are SAT vocabulary words. So you're all good, right? You can, SATs, no problem. When you're actually trying to evaluate reading and you want to know, has our teaching of reading or something like reading been successful? Typically what we do is give people reading lists and see, can that child, that student, read these words? And you get a kind of yes or no, right? They can or they can't. Sometimes the errors that they make, if they can't read the words, then the mistakes can be informative. That can help you understand what might be going wrong. But essentially, if the child can't read something, then you don't know why, because all you've done is look at the end result of all of those complex behaviors. You see what I mean? So if you're trying to help a child learn to read, or if you find somebody who does have difficulties with reading, then you're a little bit lost, a little bit stuck, because you don't know at which level this extremely complex process is broken down. Then what we end up doing is kind of guessing, right? We have a lot of strategies, some of which we know work with some people some of the time, and so we kind of grope around trying to find the right strategy for that person at that stage in their development. And sometimes we'll get it, and sometimes we won't. Sometimes we'll be able to help, and sometimes we can't. We would much prefer to use an approach that's come to be known as evidence-based practice, right? Where we actually have evidence that helps us determine which is the right approach for a particular person at a particular stage. And this is the kind of thing that I argue brain science is really good for that, because precisely what it does is it looks behind those observable behaviors. It looks at the sub-processes that lead up to things that you can quantify just by observing. Does this make sense? So this is why, like, this is what we try and do. What we actually have is we've got a lot of literature and experience that really allows us to tell, when we look at brain responses to tasks like this, where in the process has something gone wrong. You know, because the timing of brain activations is very, very fast. And so we can see, depending on when something happens, we can actually isolate where we should be targeting intervention and approaches and things like this. Okay. The problem, of course, is that getting that evidence is very difficult. It's a complicated thing to do. And we can't just look into brains. So we have to use our highly specialized, kind of very complicated processes in order to be able to do this. So what I'll do now is just explain a little bit about how we get to those brain signatures, right? This, I promise this is all a setup for the research that you came here to hear about, which is the mindfulness work, right? It is going somewhere. Although I have to be careful, because I literally could talk about this stuff all day. It's really, if there are any of my students in the audience, they know. They'll be like, no. Okay. So we use these electrode nets. You see these little white things on somebody's head. This is to help us measure the electrical activity that's generated by the brain when it's doing anything. Your brains are generating electricity the whole time, right? So what we want to do is try and isolate the electrical activity that's being generated that's related to a particular process, like reading or meditating or whatever it is. So we usually put someone in front of a computer, because remember, we're looking at processes that happen on the order of milliseconds. So it's no good for us to kind of, you know, hold up a piece of paper and say, okay, now read this. Okay, now stop. Because that's, you know, the timing isn't precise of that. Even if you try and do it very quickly, you don't know when something actually got processed at different stages. You know, the visual stage, the language stage, when it got translated into movement, all of those kinds of things. So we need to control the timing very precisely, and we need to rely on computers to do that for us. So we present stimuli using a computer while the person has these electrodes on their head. The electrodes are connected to a signal amplifier, because the electricity that's generated by the brain is very, very small. That's why we don't shock each other all the time when we walk by, right? So we have to amplify it. Then we have to digitize that, because everything has to be digital now. That's the only way we can actually work with these kinds of signals, right? It didn't used to be that way, but it is now. We have these big data acquisition computers, and then what they give us is readouts that look like this. And what you can see up here, see these wavy lines? Each one of those corresponds to one of these little white electrodes on the person's head. And what it's showing us is whether the voltage at that particular point on the scalp is being measured as going up or down. And we sample that 1,000 times a second for each person. We use 128 electrodes. So 1 second of collecting brain data gives us 128,000 data points, right? So you can imagine the kind of computational power, the kinds of complexity of analysis that we have to use to make sense of this. One thing that we do is, see those little flags up at the top there? The little gray things? What those are, they're generated by the computer that's presenting stimuli to the participant. And this computer is actually sending a signal to that computer saying, I did it, I did something, I showed them a word, right? And it's millisecond precise. So we look for those little flags, and then we isolate the bits of brain data that are related to those events. Then we average those pieces of brain data together, and what we end up with is these brain signatures, right? Characteristic brain responses that are typical for that individual under those particular experimental circumstances. Is everyone okay? You still with me? Yeah? Awesome. Okay, so these brain signatures, the ones that I'm showing here are actually visual brain signatures, but we have a lot of information about what they look like for many different things, for attention, executive function, language processing, reasoning, different kinds of processes, right? And so we can look in time and see how these brain signatures get modulated under different circumstances. Okay. I just want to pause for a second, because today is all about pausing, right? And I want to talk a bit about the previous research that's been done in this domain. When people are looking at things like mindfulness and investigating the effectiveness of some of these programs, we've tried many different ways of doing this, but it's become kind of a very interesting experience to engage with this literature. Research on mindfulness is still in the relatively early stages, but an increasing number of studies are showing things like benefits for physical health, psychological well-being, social skills, academic performance, and more, right? And many other studies have also showed that mindfulness can be effective in reducing stress and burnout in teachers and administrators. And so we really care about this kind of work. But we want to know which of these approaches really work, which of them are the most effective, what's the right way to implement this, right? We want it to be an evidence-based practice. But as with reading or any kind of complex cognitive process, the effects of mindfulness are really difficult to quantify because this is an internal process, right? It's not something you can easily observe. We can look at the external behaviors, but that doesn't really tell us much about what's actually happening for that person while they're meditating or what's changing as a result of the meditation. So we get very rough kind of indicators about whether the intervention worked in some way. Usually this is quantified along some rather subjective sort of rubric, like whether children are paying more attention in their other lessons, or whether they're behaving more often, more like we wish they would more of the time, right? There are a lot of examples of this kind of work. There was a study that was done quite recently that looked at African American students receiving transcendental meditation instruction. And it found that they showed, let me just read this, reduced rates of rule infractions compared to the control group. Right? So that's interesting. And who sets up the rules? And what does that actually mean? People are breaking the rules less. What does that mean about anything that actually changed for them? Is it the meditation, or is it the experience of being in a group where you all sit together and do something together, and someone is paying attention to you, kindly attention, right? The kind of attention that Kelly pays to children. Like, all of those things have effects as well. How do we determine what's actually due to the meditation? Some researchers looked at other measures of stress, like cardiovascular function, that kind of thing, blood pressure, to see if those go up or down. But again, if you sit quietly and breathe for a second, that's going to change your cardiovascular responding. It may or may not be the mindfulness aspect of the work. Some researchers tried to get at the internal effects of mindfulness by literally asking questions about it. So ask the people who are participating, do you feel that you focus better in class since you've been doing these mindfulness practices, right? Or do you feel that you have personally benefited from taking part in the mindfulness practice? But here's the thing with that. Think about any child you know. Imagine taking them out for some experience, right? Giving them some attention, take them to a museum or something like that. And then afterwards say, do you feel you benefited personally from that awesome outing I just gave you? Right? And what are they likely to say? I mean, most people, and certainly most children, will say, yeah, of course I did, right? It doesn't necessarily reflect what their true internal state is. So there's all kinds of problems with the ways that we try to evaluate the effectiveness of these programs. This picture is actually up here because it was a recent report in the New York Times that said it actually gave the impression that if you participate in mindfulness experiences, you will exercise more. And this is not what the study said. What the study actually found was that people who engage in mindfulness experiences are less dissatisfied with their exercise routine, whatever that might happen to be, right? The behavior didn't actually change. So there were effects of the mindfulness intervention, but it didn't alter the behavior. So if you're looking at something only from the outside, then you really can't see what those effects might be. Okay? So this is why actually it's really important for us to use the technology and scientific methods that we have available to give us some quantifiable and objective outcome measures in this situation. I already talked about one of those approaches, which is the EEG approach, the EEG and brain signatures, these ERPs that we use. We know about those particular brain signatures associated with executive function and attention, orienting to a problem, making a decision. So we can look for those brain signatures before and after, and even during a mindfulness intervention, and we can see, are there actual effects on brain function? If we do the experiment right, we can even tell whether it's most likely to be an effect of mindfulness or whether it's probably an effect of something else, like all-round wonderful teachers, right? Or changes in the home environment, changes to parental instruction, those kinds of things. But we have to be very balanced and careful about the way that we design our experiments. We can also look directly at other biological systems. So there are specific measures of stress that can be quantified, for example. We can see directly and objectively whether mindfulness approaches have effects on these biological systems that underpin stress experience. And not just by asking some child, you know, are you feeling less stressed since you've been coming to yoga class, right? Like, we can actually find out. So let's have a quick look at some things. Oh, attention. I just saw these little yellow triangles and I thought, what's wrong? There's something wrong. No, that got my attention. Okay. So attention is actually kind of a complicated concept. It's really something that's only recently being well understood, especially in the human brain. The brain actually receives so much information all of the time that decisions have to be made about what aspects of that information actually require additional processing and what can be ignored or filed away for later on. The process of making those decisions, which is unconscious, right? You don't get to decide consciously whether I'll pay attention to this or not. It's an unconscious, extremely rapid, kind of basic process. And that decision is what we refer to as attention. As we'll see in a second, attention isn't a unitary process. There are different kinds of attention, and they result in different brain responses. But we do know that attention is mediated by this very complex and active network of brain regions. You've already been hearing a lot about the amygdala, the limbic system, and the prefrontal cortex. But also what's involved is part of the thalamus, the pulvinar nucleus, which is part of the cognitive thalamus. That in turn mediates prefrontal cortex. The superior colliculi, which are nuclei that are important for sensory processes. The anterior cingulate cortex, which is a small piece of frontal cortex. It's not shown very well on here, but it's tucked away in the middle of the brain. And that's very important for decision making and for resolving kind of complex decisions. The parietal lobes, which are association regions of the brain, so what they do is take information from a lot of other places and coordinate that information. And of course the frontal lobes, which is where a lot of that information ends up. There are specific ERP, those electrical signatures of attention. One that we call the P300. It's just a name for it. It doesn't matter. It could be called Bob, right? It's fine. So it's called the P300. And what we can tell from this is that less relevant information actually undergoes less processing. So if you're doing some kind of task and you see something that's not really related to the task, then what we see is this kind of flattening of the P300. See where it says inhibition here? That brain response gets attenuated in a way. But if you see information that's very pertinent to the task that you're doing, then we see the P300 getting bigger, right? So we can really directly observe how the brain is handling these kinds of complex attentional processes. Something else that means we should be aware of in studying attention is that we know that network that supports it really develops quite late in development. So the NIH made this little movie that I hope is going to work. Oh, Yes, it would if I just left it alone. Try again. So the NIH, the National Institutes of Health, made this little movie that shows brain maturation. What it actually shows is in red and greenish colors, those are less mature regions of brain. And as things turn blue and purple, what you're seeing is really refinement of the cortex. Not necessarily thickening, but refinement. In some cases, that means some cortical growth. In some cases, it means minimizing the amount of gray matter, right? So that you get more efficient processing, more efficient pathways. So more mature is the blue-purple, less mature is the green, red, orange, those kinds of things. And what you can clearly see is that parietal lobes, which are kind of up here, and parts of the frontal lobe, and parts of the sensory processing cortex are very slow to mature. This movie, it only takes a couple of seconds to loop through, but it takes you from age 5 to age 20. So even by the age of 20, a lot of these brain areas still have not fully matured, and people are still learning to engage their attentional and executive function networks. So again, this is important for us when we're evaluating mindfulness programs, because we want to know, can mindfulness strategies and approaches help us to advance that maturation process? Okay. Stress is a slightly different but related matter. Our colleague Kim Noble has done a lot of work on the impact of socioeconomic status on stress. We know very well at this point that socioeconomic status influences the linguistic environment, which then changes brain development in language-related areas, the left hemisphere usually, in the temporal, occipital, and inferior frontal regions. And so that can actually change linguistic abilities. But stress is also induced by being part of a low socioeconomic status situation. And that affects development of these very key areas, the hippocampus, which subserves memory, the amygdala we've been hearing about, which has a lot to do with social emotional processing, and the anterior cingulate, which is that important piece of the frontal cortex that's very late to develop anyway, and it's involved with cognitive control and regulating one's own emotional responses. So the impact of socioeconomic status and how stress actually mediates brain development, that's also something we can look at when we're examining mindfulness practices, especially when we have a wonderful school like this one in the Bronx, right? This is not a private school. This is not people from a high socioeconomic status. These are people who often have socioeconomic difficulties to deal with. And so we really have a wonderful opportunity to examine the interaction of mindfulness on stress that's related to low socioeconomic status. Stress is mediated by chemical pathways that do impact brain development and adaptation. I'll talk about those just very, very briefly. But basically, the problem is that humans aren't all that evolved. You know, you still hear stuff about paleo diets and Bronze Age brains and things like that. I wouldn't quite go that far, but we do have very basic kinds of responses that aren't really adapted to everyday life in the 21st century. So when brain functions are triggered, when stress is triggered, it's a more hyperactive situation than we necessarily need, right? Getting a stressful text is not the same as having to run away from a saber-toothed tiger, right? But the brain doesn't differentiate. It's essentially the same chemical response. But the good news is that the brain and other systems are incredibly adaptable, that even though chronic stress can cause these kinds of problems, there are possibilities for adaptation and recovery from that damage. Humans, you know, we adapt in good and bad ways. So some of us go to the gym and meditate, you know, find a good therapist. Some of us eat extra chocolate cake or abuse various substances or don't get enough sleep, those kinds of things, right? Those are all adaptive responses. Some are helpful and some not so helpful, but they're all responses to the stress situation. And then we also need to think about this key concept of allostasis. Allostasis is this dynamic process where homeostatic control, so how your body is regulated, is maintained by adapting to physical and behavioral stresses. And it leads to this, this concept of allostatic load, which is about the wear and tear that's induced on the nervous system as a result of these changes in allostasis. Okay, a little bit complex, so just a quick picture to illustrate. Basically, we have chemical and biological pathways that go from the perception of stress in the brain. You know, experiencing a stressful situation as perceived by the brain really stimulates these physiological pathways. It results in changes to the levels of various hormones in the bloodstream and in the saliva and other bodily fluids too. So the production of, for instance, adrenocorticotropic hormone, which is generated in the pituitary gland, then results in glucocorticoids being generated, and the adrenal glands secrete these glucocorticoids. Those have good effects, like mobilizing energy into the bloodstream, but they also have bad effects, like, for instance, cortisol is one of these. You've probably all heard of cortisol. It plays an important role in regulating hunger and regulating the sleep-wake cycle. So if your cortisol is off balance, then so are those aspects of behavior. As well as the glucocorticoids, we also have the adrenal medulla around the kidneys that produces adrenaline and noradrenaline, right? And those are, in the short term, adaptive hormones that allow you to deal with a stressful situation. But in the long term, those can be very damaging because they increase the sympathetic tone in the body. And that means that you end up with things like high blood pressure, poor digestion, those kinds of issues. Okay. So what we can do is actually look at some aspects of these allostatic responses to stress in children who are practicing versus not practicing mindfulness. And we can see if any of those known effects are being modulated by these approaches. Right? So this is what neuroscience gives us for the investigation of mindfulness practice. And here to tell you specifically what we've been doing about that, this is my awesome lab manager, Trey Avery. So.
Now we're getting into the nitty-gritty, so if it's too much, just close your eyes and fall asleep, and I'll just pretend you're meditating. All right, so we've got a couple minutes here to sum up about 5 years of research. Mindfulness is a very kind of hot topic right now. So you've heard of mindfulness-based stress reduction. It's been studied in all of these different conditions. It started off about 30 years ago at the University of Massachusetts Medical Center. And today, or let's see, 2013, we're up to about 550 publications, which is a pretty kind of hot area. So go and find your condition of choice and then go, search around for it. But it's really interesting because it's very effective in helping with lots of different conditions. As Karen talked about, it's very hard for us to measure these very kind of complex concepts of consciousness. So, when you're talking about even someone, perceiving a word, that's simple compared to consciousness, like the whole thing. So we have to use these very small measures. And so what I'm doing for my dissertation is looking at these very small measures of attention in children that are meditating. And as we talked before, it's very funny having these kids in the lab. We started off trying to kind of qualitatively kind of say, okay, well, we're seeing this response, but then we're going to ask the kid, okay, so how are you doing? And every single time, the kid would be like, great. And you're like, you seem like you're about to cry. And you're like, I'm good. And you're like, okay, well, we'll work through this. And so we were like, okay, we may have to work on that a little bit. The basic kind of cognitive components of mindfulness practices are the regulation of attention, awareness of body and senses, the awareness of the environment, and regulation of thoughts and emotions, and metacognition. I'm just going to leave that there for a minute in the interest of getting towards the data. All right, so we bring the kids into the lab, and we have them do this task. It's called the Attention Network task. We lure them in saying it's a game, and they find out within 2 seconds that it's the worst game ever. They sit there and click in the direction that the fish are pointing. And they get this upset face like, you lied to me. But it allows us to be able to separate different forms of attention. So we're able to see how they alert. So when they see one of these little cues right here, it alerts their attention, and that tells us something about how they can kind of direct their attention. As well as kind of orienting. So if it's orienting in a certain direction, or a more complex version of when they're looking at congruent versus incongruent, so when fish are going all one way, or fish are going in different directions. So if they're going one way, it's a little easier for them to respond, and it takes a little more executive control if they're going different directions. They start off like this, smiley and cute, and then by the end, they don't want to talk to us anymore. All right. So we put these EEG nets on kids, and people are even bold enough to put them on babies, and babies yank around them and pull the wires. And as a lab manager, that terrifies me. But we're looking at these occipital electrodes right back here in the back of the brain, right in the back of your head. And so what the data that I'm going to show you is all from that kind of brain region back here. So here's to orient you to the task. So right here, this is when they're seeing one of these cues that alert or orient their attention. And then here, they're seeing a target, so it's a bigger response because it's a more salient thing. It's, a little star on the screen. It's not too exciting, but you still get this response. But then when they see a fish, they get a little bigger response. And then when they're judging congruency of the fish, you get a bigger response because it's a more complex task. And so, go. Okay. So this was a small pilot study that we did of adults that were going through mindfulness-based stress reduction, which is an 8-week program where you learn different kinds of mindfulness practices. And the one takeaway from this message is that this was only a very few participants, but you'll notice the small difference here. So when they're looking at the congruency of a target, this is before, and this is after. This double peak is kind of a signature of kind of more development in that area, more control. Hold that thought so that when I show you the kid data, it's basically just kind of evidence that we're seeing some changes over this 8-week program. With more participants, you'd see more changes. This is to say that there's tons of data. We're not going to get into it, but it's there. And we're going to focus today on this later component that I've been talking about. So this is the measure of executive function that is judging the congruency of the fish on the screen. So these are the control kids recruited from just around the New York City area. We're doing our best to kind of match them to the kids in Kelly's school. But you'll notice that there are some differences. You can either see that in the bar charts, or you can see that and that the squiggles are reversed. And so at first, we of course were like, okay, this is a pilot study. Brain data isn't, you don't just happen to find these huge significant effects, but I seem to have stumbled upon one in my dissertation. So with only comparing 4 kids, we're seeing these consistent effects where the control non-meditating kids are having this stronger response to congruent trials, whereas, yes, so, and then the meditating kids are having this double bump response that you'll remember is somewhat like the adult response that we saw. And so when we look at where that activity is occurring, we actually find that there's activity in the meditating kids in the frontal regions that we talked about. And remember, these are 5- and 6-year-olds. That was like one of the last developing areas. But in these meditating kids, we're actually seeing some increased activity of these early executive processes that usually don't develop until later. So these programs are actually having an effect. And these are the things that make me feel like I will graduate someday. The statistics are good. So in addition to this, we also measured saliva, measures of stress. And so again, saliva is even more, in some ways, complex than the brain measures that we use. But you see some interesting trends. So The blue lines are the mindfulness kids. You'll notice that cortisol, which is a marker of stress in saliva, the kids consistently have lower levels of baseline cortisol, so they come in less stressed. But then interestingly, we have alpha amylase, which is a more short-term stress response. So it's more kind of short-term reactivity to an immediate task at hand. And the thing that we noticed was that the kids that meditate were actually more engaged with the task. So if they would if they would click the wrong way one time, they'd go, oh. But the kids that didn't meditate would kind of go like, yeah, I got it. So we see that as kind of more engagement with the task. And that's a kind of normal reactive response. That's a healthy response to a stressful situation. And then this last measure is a measure of kind of immune reactivity that we see is, again, we see it as probably a healthy immune response to a possible stressor. The kids that don't meditate kind of have a flatline response where they're not actually seeing kind of this immune response and then relaxation. So the takeaway message is that in our preliminary data, we're seeing some very interesting findings in terms of possibly early development of these frontal networks that are very important, and differences in stress regulation. And this is what I'll be doing for the next 20 years. So more to come. And